That's why we're doing this. We want to be able to test these technologies and turn it over to industry to incorporate into the next generation aircraft.
That is so important. We just don't do technology just for technology's sake. It's actually about transitioning it and getting it out there and having people use it and having an impact. That's what we're all about at NASA, is having that impact.
I think above all this, students need to feel that they not only belong, but that they're also making valuable contributions to the projects that they're working on. And NASA mentors and leadership, in my experience anyway, are highly trained to provide students with opportunities for growth that'll positively impact other aspects of the students' lives, whether that be back in school or elsewhere in their lives.
Because at the end of the day, all of these considerations combine holistically to allow the whatever measure or whatever product that we're developing to continue to exist and to continue to serve us to better our quality of life. So I don't think it's just a discussion on the environment, but also taking into account all of these other factors as we go forward.
Hi, I'm Taco Kubota. I'm a PhD student at the University of Delaware, Department of Material Science and Engineering, doing some exciting research at the Center for Composite Materials. I'm working with an exciting new class of material called TUF, which was developed at the University of Delaware. We take short carbon fibers, align them, and create blanks which can be stamped like sheet metal while achieving continuous fiber composite properties.
In almost every class tested, at least one child, and often as many as 4 or 5, wrote words on the walls of the lab that said things like keep out, private, do not enter, go away, top secret. There is this perception not only that scientists are these weird mythical creatures, but also that science is closed. It is something that is dangerous and you must keep out and leave it to the crazy scientists. And that is a problem. That is a perception that scientists need to correct.
And so when you think about exploring those edges, realizing that some people are going to feel really comfortable in that core of whatever you're doing, and other people are going to feel more comfortable out at that fuzzy edge where I'm trying to plant my flag in the ocean, and other people are going to be comfortable in the middle. And that is a tremendous value to you as an organization to be watching for that and to see who is uncomfortable when. And I like to think of it in terms of the ancient maps and the dragons.
Couple reasons, but one of them is because we're designing for a 30-minute flight on the battery. So you're not really going to do transoceanic on this unless you're hopping along a coast where you're still within landing space. But our size is 180 passenger, which is like a big single aisle.
But the modern day of innovation, I think, is more iterative, where you still have to have that imagined vision, but that you don't actually try and build it out of the gate. You say, what's the fastest, simplest thing we can do with the highest probability of success? Build that. Now, what's the fastest, simplest thing we can do with the highest probability of success to either move a step closer or to improve? And you keep building and building and building until what ends up happening is you go right past that imagined vision and you end up building the unimagined vision. So I think that iteration, rather than trying to build the thing over the course of decades, is become more powerful, and the ability to drive right past that imagined vision and build the unimagined vision, I think is how we need to start thinking. And it is how you think when you're at your natural best anyway.
Decarbonizing the economy and eliminating the climate impacts from all the industries that are surrounding us, while maintaining our way of life and supporting the improvements in the ascending world in countries all around the globe, is probably the most exciting technology and engineering challenge of a generation, or maybe two. It might take 2 or so.
As a government agency, we're not tied to that do or die, I have to sell this product. We can lean forward and take some risks. We can take some chances. Our job at NASA is to learn. And by learning, we can tear down and burn down some of that risk that's out there so that we can actually encourage industry or enable industry to lean a little bit more forward.
Industry isn't equipped for fundamental R&D. When I first started working for NASA some 38, probably pushing towards 39 years ago, My supervisor told me that NASA's role was to be like the pilot fish out in front of the whale, seeking new technology developments that would allow for, again, that new food, that new growth.
Imagine a safe and affordable transportation system that embraces emerging trends in data science and intelligent autonomous systems. A world where aircraft are eco-friendly and where land can be used for green space instead of highways. Imagine a transportation system that will create new job opportunities.
No matter what you're designing, you could be doing it faster and with a lot more physics by using OpenMDAO. So please download it, use it, borrow code from it, or simply take inspiration from it. What could you design if your optimizations ran 10,000 times faster, or you could couple in high-fidelity physics into your system models? To get started, visit openmdao.org.
Aviation that we understand today with the big airlines and the feeder airlines becomes something very, very different, very diverse and differentiated. And you've got all the possibilities there, from urban delivery drones and air taxis, middle mile logistics, intercity flying, all the way up to supersonic, hypersonic, transatlantic, transoceanic flight, and space access, both delivering cargo via space or even passengers via space.